Now we will discuss the admittance matrix. This is a very important part for load flow analysis, right? So when there are, let us say, n number of buses present in the power system, then the admittance matrix, it is going to be an n into n matrix. So it is represented usually by capital Y. So this is the admittance matrix and its order will be n by n if there are n number of buses. Now we will see what are the elements of the admittance matrix. So the admittance matrix, if you represent as capital Y11, Y12 and so on till Y1n, right? And in the second row you have Y21 so on till Y2n, and similarly the last row Yn1 so on till Ynn. This is n by n matrix. Now what are each of these elements, right? So if you take it in general as Yij, each element we represent as Yij. What is I? It is the number of row and j is the number of column. Now when I is not equal to j, then Yij is equal to negative of the admittance between the ith bus and the jth bus, the transmission line that is connected between the ith and the jth bus. Okay, so you can write here where Yij is, see, remember here it is a small letter. Okay, so small letter represents the actual admittance of the transmission line that we are considering. Capital Y, if we are taking, it is the element of the admittance matrix. Okay, so here small Yij is the admittance of transmission line connected between ith and jth bus. Okay, now when I is equal to j, then what is going to happen? When I is equal to j, then Yij, this is going to be equal to the sum of all the admittances that are connected to ith bus. Here I is equal to j, so I or the jth bus. Okay, so this you can take as equal to Yii or Yjj, whatever is the variable, right? So this is going to be equal to Yi1 plus Yi2 plus so on till Yii plus so on till Yin. Okay, so what is Yii here? This is the admittance between the bus and the ground. Okay, because the bus is going to have some ground admittance. Between the bus and the ground there is going to be some admittance component. Okay, so that we represent as Yii. Okay, and the rest of the elements anyways, what is Yi1? This is the admittance of the transmission line connected between ith and the first bus, here between the ith and the second bus, and so on. Okay, now what we will do is we will try to understand the admittance matrix, how to form an admittance matrix by means of an example. So here we have a single line diagram. Okay, so this is called a single line diagram. Here we have bus 1, this is bus 2, bus 3 and bus 4. Okay, and the transmission lines, these are connected across all of the buses, and the parameters, the admittance parameters are represented. Okay, so and all the admittance values are also given. Okay, so now we need to find out the admittance matrix. So let us see how to do that. Firstly, the number of buses here are 4. So it will be n is equal to 4. So the matrix that we are going to get, it is going to be a 4 by 4 matrix, right? So here it is going to be Y11, Y12, Y13, Y14. Okay, and so on till Y41, Y44. First we will start with the non-off diagonal elements. Okay, so that means this Y12, Y13, wherever I is not equal to j. Okay. So first if you see y12, what will this be? This will be negative of the admittance between the admittance of the transmission line between the buses 1 and 2. Okay. So it is already given here y12, what is the value? 0.96 minus j 4.8. So this will be equal to negative of that admittance, which is minus 0.96 plus j 4.8. Similarly, y13 you can write as minus y13. Okay. So this value is also given here, it is given as 4 minus j8. So capital Y13 will be equal to minus 4 plus j8. Now the last element in this row, y14. Now you can see that there is no transmission line between bus 1 and bus 4. So what will be the admittance? It is simply going to be 0. Okay. So y14 is 0. Now what is y21? This will be same as y12 because it is also the admittance between transmission line 1 and 2. Okay. So this also you can write in a similar manner. You can complete all of the off diagonal elements. Okay. Now we will see the diagonal elements. This is for I not equal to j. Now what about I equal to j? Y11 will be equal to all the admittances that are connected to bus 1. Okay. So this is y11. This is what the ground admittance. So we will see what that is. Plus y12 plus y13 plus y14. So y12, y13, y14 anyways you know. We just need to find y11. So here if you see at bus 1, you have, this is one transmission line, this is one transmission line. Now the admittance of this transmission line at this end is y120 and here this is y130. So y11 will be equal to y120 plus y130, as simple as that. So what is y120? It is given j.5 and y130 it is given as j.5. So y11, this is equal to y120 plus y130, which is equal to j1. Okay. So substituting all other values, you are going to get y11, this is equal to 4.96 minus j 11.8. In a similar manner, you can find out y22 is equal to y21 plus y22 plus y23 plus y24. Okay. So similarly, y22 also you can find what is y in the second bus here. Two admittances are y240 and y210. Okay. So 240 it is given j1 and 210 is given as j1. So y22 is going to be j2. In this manner you can complete the entire admittance matrix. I will write down the final value. Y is equal to 4.96 minus j 11.8 minus 0.96 plus j 4.8 minus 4 plus j 8 and 0. Similarly here minus 0.96 plus j 4.8, 2.61 minus j 9.02, 0 minus 1.65 plus j 6.22. Minus 4 plus j 8, 0, 5 minus j 10 minus 1 plus j 3, 0 minus 1.65 plus j 6.22 minus 1 plus j 3, 2.65 minus j 7.22. This is the final admittance matrix. One more topic here is the modification of the admittance matrix. So how to do that? Let us say the transmission line between buses I and j is removed. Okay. So transmission line between and j buses is removed or added. Okay. So what is going to change? Yij, small yij is the only admittance that changes. Okay. Now if Yij changes, then what elements are going to see the change? The elements that are going to be affected by it is capital Yii, capital Yjj and Yij, Yji. Okay, so these are all the elements that will be affected due to change in Yij. So that can be either addition of transmission line or even a removal of transmission line. So this is the first one. The second one is the shunt admittance. Addition or removal of shunt admittance. Okay. So let us say ith bus, if you are taking, say ith bus, then what will be the parameter that is going to change? Small yi will change, and when this changes, it is going to affect only one parameter. What is that parameter? Capital Yii. Okay, so we will take the help of an example. We will take the same example, but what we will do here, we will remove the transmission line between bus 2 and 4. Okay, and then we will find the admittance matrix. What will be the modified admittance matrix? Y24 new is 0, Y24 new is equal to Y420 new is equal to 0, because now there is no transmission line. When there is no transmission line, there is no admittance between that line and the ground. Okay, so now what are the parameters, the admittance matrix elements that are going to be affected? From here, from Y24, the elements that are affected are Y22, Y44, Y24 and Y42. So now if you take all the new values, okay, so Y22 new, this is going to be Y22 old, whatever the previous value was, minus Y24, because there is no transmission line, and minus Y240, only that part of the shunt admittance which is associated with the transmission line between 2 and 4, not the entire Y22. Okay, so this, if you subtract, you are going to get 0.96 minus J 3.8. Okay, now Y44 new, this is going to be the old value Y44 old minus Y24, anyways it is there, minus the admittance associated with only this transmission line. So what is that? Y420 minus Y420. So this is going to be 1 minus J2, and Y24 new, anyways it is going to be simply 0, because now there is no transmission line. Similarly Y42 is also going to be 0. Okay, so this is how you can modify. The modification of admittance matrix is very simple. Now we will see what are the advantages of using the admittance matrix. First advantage is it is a sparse matrix. That means most of the elements are 0. So why that is the case? If you consider a system, not every bus is going to be connected with every other bus. Okay, and if there is no transmission line connecting two buses, then that particular element is going to become simply 0. Okay, so this is because not all buses are connected with every other bus. So majority of elements of admittance matrix are 0. So this is going to reduce the memory as well as the computation time. So this is often done in computer systems, right? And there memory becomes a very important factor. Okay, so memory and computation are saved, computation time are saved because of the sparsity of the Y-bus matrix. The second point is the formation of the admittance matrix is quite simple. Okay, formation of admittance matrix is easy. And finally, the third point, any changes in the transmission line system, it is going to be easy to incorporate or modify in the admittance matrix. Okay, any changes in network can be easily incorporated in admittance matrix. So these are some of the advantages why Y-bus is used in load flow studies. So we will see later on the Y-bus, it is used for load flow anyways, that we have discussed. Now the Z-bus matrix, that is the impedance matrix, this is going to be used for fault analysis. So when we do fault analysis, it will become clear to you.